Hi folks, let's take a look at a solution for question 6 from the September 16 homework. Okay, and it asks if x minus y is a factor of x cubed minus y cubed. So again, what I want to try to do is see if I can recycle some of the work we've already done with factors of polynomials. So I'm going to consider this polynomial here, x cubed minus y cubed, as a polynomial x cubed. Okay, plus 0x squared plus 0x minus y cubed. So essentially the y cubed here is the constant coefficient for this cubed polynomial. So what I'm going to do is I'm going to divide this polynomial by the linear expression x minus y. We notice that the coefficient of x, or the leading coefficient of x minus y, is 1. So we can use synthetic division in this scenario and use it directly. Okay, so let's see what happens here. So let's set up our synthetic division. Okay, now remember, we're dividing by x minus a. So in this case here, what is the a value? It's just y. So I'm going to put y to the left of my division symbol. And then to the right of my division symbol, I'm just going to put the coefficients of the dividend. Okay, so here, coefficient of x cubed is 1, coefficient of x squared is 0, fixed coefficient of x is again 0, and the coefficient, or the constant coefficient here, is just negative y cubed. Okay, so let's go ahead and do the division. So bring down the 1. Okay, so y times 1 is y. Okay, so now let's add 0 plus y is y. Now y times y is y squared, so that's going to go here. And now add vertically, 0 plus y squared is y squared. And now y times y squared is y cubed. And negative y cubed plus y cubed is just 0. So that means that the remainder here is equal to 0. But what does that tell us? It tells us that x minus y is a perfect factor of x cubed minus y cubed. So let's write this down. Let's write down what this synthetic division tells us. It says that if I divide x cubed minus y cubed by the linear factor x minus y, we get, and here let's take these terms, represent, remember what they represent, the coefficients, okay, to my quotient. So 1 represents the coefficient of x squared, so I have x squared. Okay, y represents the coefficient of the x term in my quotient, so plus yx. Okay, and y squared represents the constant coefficient in my quotient, plus y squared. And since there's no remainder, this is the division. But now let's rewrite this in our other form. Let's multiply the x minus y to the other side. What do we have? We have x cubed minus y cubed is equal to, well, x minus y. Okay, and now we usually tend to rewrite this expression here with the x coming before the y. So x squared plus xy, I can do that since multiplication is commutative, plus y squared. Okay, but now I want you to look at what we've achieved. We've managed to write x cubed minus y cubed, in other words, a difference of cubes, in this factorization. Okay, so remember how we have a factorization for difference of squares. We've in fact stumbled upon the factorization for difference of cubes. Now what you might want to do as a little bonus here is consider, is x plus y also a factor of x cubed plus y cubed? Okay. Okay, is there a factorization for the sum of cubes, which is something that I alluded to earlier. So I'm going to leave that as an exercise for you to look at. Okay, that's it for now.